D6 because these are perfect squares, right?
Oh.
4 squares. So that gives you
What's the right
91. Add 49, that gives you 140.
That's stupid.
Do I get an extra credit point?
So that's what we're going to be doing in this section. A lot of things kind of like this.
Yay! I'm so excited.
These are called sequences. Has anybody played the game Sequence before?
No,
Yes,
my
I
mom
have.
plays it.
And I hated it.
I've never played it before, but other people have had pretty good reviews on the game actually.
No. Have you?
So in this game Sequence, you have basically have a deck of cards and you play cards and then you get to put your like tokens where that card is on the board and you try to get 5 in a row. So you try to get a sequence of 5 in a row. And we're going to be doing a sequence of 5 terms in a lot of these questions. So let's start with this. What a sequence is. You don't have to know the definition, but I'm going to explain to you what a sequence is first. And then most of the time we're going to be either writing like the first 5 terms of the sequence, or we're going to be given 5 terms and we've got to come up with like a formula for the sequence. So a sequence is a function. Okay, so you can think of like an f of x function. Except in sequences we generally use n's. So I'll call this f of n for right now. Alright, so f of n, and it could be any function like, instead of like say 2x plus 1, or let's say 2x, it could be, just say 3n. That would be a sequence. 3n. And what makes this unique is the domain of this is the set of all positive integers. So what's a positive integer?
1,
0.
Well, not 0. 0 is
1
yeah,
through.
yeah, 1 through infinity, just added by 1 each time, right? So 1, 2, 3, 4. So what this is saying is, if we were to plug in all of the positive integers, say f of 1, so that would be 3 times 1, which is 3, right? F of 2, 3 times 2, which is 6. F of 3, which is 3 times 3, which is 9. And so if you keep going up, you have to plug in 4. So this sequence would be 3, 6, 9, 12, 15, and it would continue on from there. So when you're given a sequence, what we're going to do is plug in the inputs are going to be 1, 2, 3, 4, and the most we'll go up to is 5. We're not going to go past 5 terms. But all it means is we're going to start with 1, plug in 1, then plug in 2, then plug in 3, then plug in 4, and then plug in 5, and this would continue on infinitely long.
So are we going to take the graph these?
We're not going to graph them now.
Yeah.
We're going to graph them. We are going to write this a little bit differently though. Instead of writing this like f of n, we're going to write it with these curly brackets. A little curly bracket like that. And if you can't draw it, you can just draw a squiggle like that if you want to, it's fine. But this is the notation that's used for a sequence. We're going to say a sub n, a with a little n there, and curly brackets, equals, and then it's going to be 3n. And actually that's going to go in curly brackets as well. So this is what's called sequence notation here. And it'll be like that on all the problems. It's just instead of writing in function notation, this is like the sequence notation. These curly brackets just tell us that we're going to plug in our positive integers. All right, so let's start with the first one. We are going to find the first 5 terms of this sequence. The sequence is called b sub n, and it's 1/2 to the n. So we're supposed to write the first 5 terms. Okay, don't worry about if your brackets aren't very good. Just do the best you can. Write some really brackets.
This together.
Yeah, we're gonna do it together. So this is your function here, this part inside of the brackets. You're just gonna start with 1, so you're gonna do 1/2 to the 1, comma, 1/2 to the second power, comma, 1/2 to the third power, comma, 1/2 to the fourth, and we're gonna do 5 terms of these. And we're gonna simplify them. So 1/2 to the 1 power is obviously just half, right? What's 1/2 squared? So you square one squared is 1, 2 squared is 4, so on. Okay, what's 1 half to the third power?
1/6.
Nope, close. And 1/8. You did 2 times. It's a common mistake. So it's 2 to the third power, which is 2 times 2 times 2. 8. Alright. Josh, see me guess one. What's 1 half to the fourth?
160.
Good. Okay, yeah. Alright. 1/16. And then 1/32. You just multiply by 2. So this is just a very basic sequence. You just plug in numbers 1 through 5. This would go on forever, but we're always going to do the first 5 terms. All right, here's our next one. A sub n equals n minus 1 over 1. And some of these you can do in your head. If you don't need to write out the whole thing, that's okay. Just you're going to do it in your head, make sure you get it right.
1 minus 1 over 1.
Huh? Yeah, so we're going to start with 1, plug it in. I'll write it all out. But again, if you can do some of this in your head, that's fine. 1 minus 1 over 1 is our first term. We just replace the n every time. Our second term, we replace n with 2. So it's 2 minus 1 over 1. Third term, we replace it with 3. 3 minus 1 over 1. 4 minus 1 over 1. And 5 minus 1 over 1. The concept of this is really like a pre-algebra concept. It's just like taking these patterns and putting it in pre-calculus notation. So this is 0 over 1, which is 0. This would be 1 over 1, which is 1. 2 over 1, which is 2. 3 over 1, which is 3. And 4 over 1, which is 4. So that's this. Everybody hanging in there so far?
Yeah. Got it.
All right, let's do a little bit harder one.
I'll do that 4%.
I'll give you a little time if you want to copy this one. So this one is S sub n, which is negative 1 to the n plus 1 times 2 over n. So a couple things about this one. It has an n in 2 places. So wherever we see an n, we're going to have to replace it with that term. So give me a second if you want to write it down.
Or you got 1.
So our first term will be negative 1 to the 1 plus 1, replacing this n with 1 and this n with 1, times 2 over 1. Right now, we won't do any simplifying yet. We're just plugging in every spot. The next term, it's our second term, so we plug in 2. So it's negative 1 to the 2 plus 1 times 2 over 2. Our next term is our third term, so we're going to plug in 3. Negative 1 to the 3 plus 1 times 2 over 3. Fourth term, negative 1 to the 4 plus 1 times 2 over 4. And negative 1 to the 5 plus 1 times 2 over 5. Now this negative 1, you're actually going to see it quite often in these different sequences. Let's see what happens here. I'm going to go through and just simplify these a little bit. This is 2, right? 1 plus 1 is 2.
Yeah.
So what's negative 1 squared?
1.
Yeah, positive 1, right?
1.
This 1 plus 1 is 2. So negative 1 squared is positive 1. Okay. So it's positive 1 times 2 for our first term, right?
Yeah.
Our next term, this is negative 1. 2 plus 1 is 3. So it's negative 1 cubed. Yeah, negative 1. And then it's 2 over 2, which is just 1. Okay. Our next term is negative 1 to the 4th power, right?
One.
Positive 1. Times 2/3. Next one is the 5th power. What's negative 1 to the 5th?
-1.
Yeah, negative 1.
Oh my god, I'm fired.
2/4 is a half. Negative 1 to the 6th power.
1.
Yeah, positive 1. Yes. So what's happening here, we got a positive and then a negative, a positive, then a negative, a positive. So whenever you see this negative 1 to some power, what it's always going to do is alternate the signs. So if you ever see a sequence with the signs are alternated every other one, it's going to have a negative 1 to the like n plus 1, or it could be n minus 1, or just n. That always is going to alternate the signs. So then if we multiply, 1 times 2 is 2. Negative 1, positive 2/3, negative a half, positive 2/5. So if ever you see them alternated, it's going to be some form of this. Negative 1 to something like that. Our next one is very similar here. So this one is to negative 1 to the n minus 1. And we'll see what happens with this one. Go ahead and you want to write that one down. We've got 3 places we're going to replace the n on this one. So we got c sub n, negative 1 to the n minus 1 times 2n over 2 to the n plus 1. This is about as complicated as these get here. Okay, so let's try our first term. Maybe we'll simplify a little bit as we go on this one. So we're getting the hang of it now. Our first term is going to be negative 1 to the 1 minus 1, right? To be 0 power. And it's going to be times 2 times 1. Actually, we're replacing all these. 2 times 1, which is 2. And then we'll go 2 to the first power plus 1. That's our first term. You don't have to simplify if you want to just plug 1 in every time, that's fine. Just going to do a little bit of simplifying though. Okay, next one is going to be negative 1. It's our second term, so we're replacing n with 2. So the 2 minus 1, which is 1, times 2 times 2, which is 4, over 2 squared plus 1. Our second term. Third term, we'll do 3. Negative 1 to the 3 minus 1, which is 2. 2 times 3, which is 6. 2 to the third plus 1. So that would be 4. Negative 1 to the 4 minus 1, which is 3. 2 times 4, which is 8. 2 to the 4 plus 1.
This might be stupid. Why do they feel the need to put the stupid brackets? Isn't that just the same thing as
Well, it's the notation that tells you it's a sequence. So it tells you that you're going to plug in 1, 2, 3, 4, 5. Yeah. That's what it's like implied by that notation. Tells you it's a sequence. Oh.
So when you're like doing the answers,
Huh?
you just like,
Do what?
like do you put the in brackets the answers?
No, well, the actual numbers are just going to be with commas separated. We're going to do this backwards in the next problem where we're going to be taking the numbers and we got to write this,
Oh, great.
which is a little bit harder. All right, next we got negative 1. We're on the 5th term, so we're going to plug in 5. 5 minus 1, which is 4. 2 times 5, which is 10. 2 to the 5th plus 1. So you'll see what happens again with the negative 1 is it's going to alternate the powers again. What's negative 1 to the 0?
0.
Negative 1 to 0.
-1.
1?
It's 1. Yeah.
One.
Anything to the 0 power is 1.
Oh, one.
Anything. Any number, any letter to the 0 power. So we have 1 times 2 over 3, comma. Next one is -1 to the first power, so that's going to be a -1. Times 4 over 2 squared is 4, plus 1 is 5. Comma. -1 squared is going to be a +1. Times 6 over 2 cubed is 8, plus 1 is 9. Next one, it's in -2 odd power, so it's going to be -1. To the 8 over 2 to the 4th is 16, plus 1 is 17. -1 to the 4th power is an even power, so it's +1.
It's gonna be our homework for tonight. We're gonna have homework like this.
Yeah. And then 32 plus 1 is 33. And last step is to simplify it some more. So this becomes +2/3, -4/5. This reduces to 2/3 as well, +2/3. -8/17, +10/33. So our 5 terms. Now, if you were to look at these 5 terms and try to write this, it would be like almost impossible to like take this and get that, right? For this one, because look, it's kind of unique here that the first and the third terms actually repeat each other. It's kind of crazy how it comes up there. So we're not going to do ones quite this hard, but there is a couple that are a bit challenging. So we're going to do the reverse now. We're going to take numbers and we're going to write the function or the sequence here. This becomes a bit more challenging. There's not as much writing though, which is nice. So let's try this first one here.
You want to take me with you?
Alright, so the easiest thing is generally to find the pattern. You can figure out what the pattern here. What's going on with these numbers? Yes, so these are perfect squares, right?
Yeah.
So this is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, right? Okay, so for our notation, we're going to do the curly bracket. We're going to say a sub n, curly bracket, equals, curly bracket, and then we have to write something in terms of n. So how do we write this?
N squared.
N squared.
N squared? Okay. So first one would be 1 squared is 1. Next one's 2, 2 squared is works, right? So it's also sometimes going to be helpful to like number the terms here. If you write like the number of the term it is. It's like this first one, if you plug it in, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 10. So that would be our sequence there. Very good.
Are we gonna have to test this?
Yeah, eventually. Not for a while, but eventually. All right, next one we've got e squared over 2, e to the third over 3, e to the fourth over 4. Right there. Sequence for this. It looks confusing, but oftentimes the first term can kind of throw you off a little bit because it'll look different. But this is the same thing as saying really e to the first over 1, right? And you can even just block that one out if it's confusing because it doesn't look like the rest of them. So if you want to try to think of it like that, then you can see, well, this is the second term, this is the third term, this is the fourth term, and it becomes pretty obvious what it is, right? And so it's going to be a to the n equals, and then what's our sequence there?
E to the n power over.
Good. E to the n over n. E squared over 2, e. All right, not bad so far. Try a couple more. And next one we've got 1, 1/3, 1/9, 1/27. And this would be the same thing as saying 1/1, right? So let's start with our a sub n.
One over n3.
All right, well, let's try. Let me write these out real quick. So you said 1 over. That's a good, at least a good place to start, right? Because all of these have 1 in the top. It seems to be common. They all have 1 in the top.
And
So let's start with 1 over. So a little bit tricky. We have for 2 we ended up getting 3. For 3 you had 9. 4 we ended up getting 27.
That's 3 times 3 is 9. 9 times 3 is 27.
Okay, but how are we gonna write it? 3 to the end.
You don't write it.
No,
I mean, like-
3 times in?
3 times.
3 in. All right, let's try that.
And so it's cubed somehow. It's cubed because
Well, the bottom's going up by
It's
times
good.
3.
It's a trick question. You can't do it.
No, you can do it.
Wait.
No, no, you can't, Mr. Davis. No, you can't.
1 over n to the third.
that's what I said. Oh,
That's what we already did, right?
No.
no, n is 3. Like that's a 3. No, it's not.
This isn't gonna work, right? Because for 2 it'd be 1/8. All right, so that's not gonna work.
N times 3 to the power.
Negative third.
1 over 1 to the power of n times 3.
1 over. Say that again.
It'd be 1 over 1 to the power of 3.
So 1 to the power of 3.
1 over 1 to the power of 3.
No, like it's already over. It's 1 over,
No.
and then
Just 1 over 3.
it'd be
Well, we tried that one. Did it work?
I mean, like,
no, and then it's gonna be it's 1 over 1.
What?
Yeah, there's a 1. There's a 1 at the bottom. There's a 1 at the bottom.
1 over 1.
Yeah, let me try.
Divided by 3.
Like I'm confused.
No, it just means 1 times
1, and then it'd be to the power of n times 3.
All right, let's try that.
I don't think that's right. Just
This would be 1 over 1 to the 0. That works for the first one. Then it'd be 1 over. We plug in 2. It'd be 1 over 1 to the 6th power. Good try.
there has to be a variable on the bottom.
Yeah, definitely has to be a variable.
Wow.
No,
It's waves.
shut up.
Does anyone think got it? You want to get
It's really hard to
to
say.
the one thing?
Mr. Davis, we're not gonna get it.
Is this hard? Is this easier than we think it is?
This is easy. We just can't figure it
It's not that hard. But
If it's so easy, I think we would
it's
figure it
probably
out.
just.
We're
3
gonna,
over
we're
1,
gonna
Mr.
struggle on our
Davis.
homework.
All right, here. 3 to the n. You guys were almost right. Okay, so let's start with this. All right, good.
Didn't we
This
put
isn't
that?
it yet, but okay. This you said this right. Now, if you plug in 1, you get 1/3, right? You plug in 2, you get 1/9, right? You plug in 3, you get 1/27. It's just they're all off by a term, right?
Yeah.
Okay.
Minus one.
Huh? Yeah, -1.
Wow.
That works.
Oh my god.
So now your first one, when you plug in 1, it's 1 over 3 to the 0, which is 1.
Oh.
When you plug in 2, it's 1 over 3 to the 2 minus 1.
Oh.
Right? Okay, so it's just all shifted down 1. Alright. I told you it's harder to come up with that, right? It's hard to
How are
go.
we supposed to figure this out? Really? Like a
Just
guess.
practice.
Mr. Davis, I think we're gonna start on our homework.
Well, there's just a few like this.
Can we go over them tomorrow?
Yeah, we'll go, bro. Alright, let's try the next one.
It's going up by 3.
Plus 2.
Okay,
N
but how do we write that?
It's just n plus 2.
N plus 2, yeah.
Well, let's try that. Okay.
Oh, great.
It's not gonna be it because the
It's
first
wrong.
one is 1. So it's gotta be. So it's
Minus 2. N plus 2. Oh, no, that's.
Okay, so yeah, it's easy to see it's just going up by 2. But how do we describe that as a sequence? Because if you plug in 1, it has to equal 1. If you plug in 2, it has to equal 3. If you plug in 3, it has to equal 5. If you plug in 4, it has to equal 7.
So start with the
This one's actually a bit harder throughout the day than the first one.
No way.
Maybe I'll just tell you this one.
Wait,
Give us, give us
wait.
a second.
What were we gonna say, Ashton?
I think that's it. You multiply it by 2.
Okay.
You subtract 1. Yeah.
Yeah, good. All right,
2 minus 2.
2n minus 1.
Yeah.
You plug in 1, it's going to be 2 minus 1, which is 1.
Yeah,
You plug in 2, it'd be 4 minus 1, which is 3. Plug in 3, it'd be 6 minus 1, which is 5. Plug in 4, 2 minus 4, 8 minus 1, 7. Very good. All right, I think I got one more try here.
1, 2, 3, 4.
These just take practice, so don't get discouraged if you can't get these.
We haven't tried to pay attention. Oh, this one has the negative 1.
Right.
It's a negative 1.
All right, hang on there. This is the last one.
This is a negative.
So this one, yeah, the first thing to notice is it alternates. It's positive, negative, positive, negative, positive.
Oh, wait, it's in.
Whenever you see that, you want to do your negative 1, and then
It's a negative 1.
yeah, it is going to be that, yeah. Yep. All right.
It's 1, 2, 3,
Yo.
4, 5.
Well, we
Yeah.
also
Yeah.
need an end. And when you get to this part with the power, you have 3 options you can do for this power. One, let's just try this. If I were to just do negative 1 to the end, okay,
That's not an alternate.
it would still alternate, actually, because if you plug in 1, it'd be negative 1. If you plug in 2, it'd be positive. 3 would be negative. 4 would be positive. So this would alternate. But we start with a positive term, right? Positive first. So if we plug in 1, that's going to be a negative first, right? So if it started with a negative instead, then we would want this if it started with a negative. But since it starts with a positive, we either want to do plus 1, or you can do negative 1. It doesn't matter. You do n plus 1 or n minus 1. We're going to start with that because this will start with a positive, because we'll start with negative 1 to the second power, which gives us positive. It'll alternate it. So we're going to start with that. And then, yeah, if you look, it's just 1. If this is our second, third, fourth, fifth. It just is 1 over n for each one. So that is our formula there. Negative 1 to the n plus 1 times 1 over n. Now, these are not easy, I know. It seems easy when you see it. Like, oh, why didn't I get it? But yeah, it's not easy to do. I know it's not. So for your problems, I want to show you real quick. And then you can have some time to work on the quest if you didn't get that done. But let me show you.
The what?
Oh, yeah, I could work on the class 2 minutes.
The what?
Or
I'm doing mine. The West.
The quiz.
so for the first section,
Oh,
you have to write down the first 5 terms. They're going to be evens. So 18 and 20, you're going to be doing those. It continues on the next page. You've got like 3 or 4 more of those. And then you have 4 here where you have to try to write the pattern. There are a couple of them that are challenging. Like this one, number 34, is really hard. So don't worry if you can't get it. Just try it. But if you can't get it, it's okay to skip it. We'll go over tomorrow. But I think you can get the rest of them. Number 30, 32. Try your best to get the rest of those.